Okay, so I'm going to take you through some of the basics of using the design accelerators in Inventor that will help you to finish this coursework in double quick time, I hope. Now you can see that I've got this this basic assembly put together, and you'll see that I've got these build planes here and a very simple sketch. Now that is actually in a separate IPT file. It was the first file that I brought into the assembly, and it's a series of planes. I've got my XY plane, I've got the centre of the right hand drum, the centre of the left hand drum, and I've then got this little plane here which is the centre plane of the drive sprocket. That's probably the most important one to bring in, and on that is a sketch over here, and it's just a simple line. All that's doing is giving me a line that I can select later on in order to be able to slide the drive sprocket along to get the correct chain length. So let's just go back to the sample assembly that I've got here for you, and you'll see what I've done is I've brought this is the first part that I brought in. I've then brought in some simple revolves which I've used for the drums, and then I've used the chain generator. You can use the belt generator as well in order to produce the sprockets, and then I've used the shaft generator to produce the shafts here. I've already done, you probably don't need to do this one, but I've done this one here. That is the shaft there. Okay, and I've started it, it's got keyways cut into it, it's got circlip grooves, it's got all the correct fillets and chamfers built into it. Because each one of these is a section within the shaft, and you can see them being highlighted alternately. Okay. So this is the first section. This is where I'm going to be putting my bearings. It's 65mm in diameter and it's 50mm long. It's then a shoulder up to the next section, which is 75mm in diameter, but that is only 10mm long. If I zoom in, you can see that it's only 10mm long, but it's got a circlip groove built into it. So I've used this down arrow here to add a circlip groove. If I click the ellipses, it gives me a little diagram of how that circlip groove is sized. And that measurement X is actually 0.5 of a millimetre, but it's measured from the second edge. The first edge is the left hand edge, and it's measured and referenced from this datum point. So the second edge is actually that one there, and I want it 0.5 of a millimetre back from that edge. Now the reason for doing that is I could have put this in as one long section, but by splitting it up I've determined that that is what's going to stick out from beyond the edge of the drum. So I can then mate that shoulder there to the drum, safe in the knowledge that the correct amount will stick out from this end of the drum, and I'll have a 0.5 of a millimetre gap between the circlip groove and the edge of the drum, and it's just this side of it. So if I just show you what I mean by that, if I select from the first edge, it would measure it from this edge. So I'm selecting it from the second edge there, okay? So accept that. There's no feature. This little thing here shows that there is no feature. It's just sort of greyed out. There's no feature between these two sections because the same diameter. There's no need for a feature. But here, on this section, I want there, it's 220mm long, and it finishes here, and I want there to be a small fillet down in here. I've just defined a 1mm fillet in order to use as for my stress concentration factor calculations, and that is defined here. So I've picked a fillet. I could have had a chamfer and a sharp to take a sharp edge off, but I've actually applied a fillet. Okay. The next section is where it goes up to 85mm in diameter to go through the main driven sprocket, and this section then drops back down to 75mm in order to go through the next hub. So if I drop back out, you can see that over here. I've then got another short section, which is only 10mm in diameter, in length, and again I've done that so that I could put a circlip groove in here. So again, I've clicked this down arrow, I've added a circlip groove, and here it is. And when I click that, you can see here that I've had to measure it from the first edge this time because I want a 0.5 of a millimetre gap between the drum that's going to slide onto here, and then so I've had to measure it from the first edge because we're building from the left all the time. Okay, and then I've got my final cylinder here, which is where I'm going to have my bearing. I haven't yet put the circlip groove in there, and you can see I've got a fillet in here. Look, I've put a fillet on the left hand edge of that section. On the right hand edge I've just got a straightforward chamfer. Okay, so that's how that shaft is built up. And when I click OK, it goes away and rebuilds it, and that's what we've got. Okay, so that's actually a very quick and easy way of building a shaft. The dialog boxes take a little bit of getting used to, and it will dump the shaft that you've created into the assembly just where you click. So you then have to go through the pain of aligning the axis with the axis of that first sketch that I showed you. So you'll align that probably with the z-axis of the first sketch. And then you can, when you start to put your chain drive in, or your belt drive, you can then start to mate these shoulders up with the various components that you bring in. So it becomes very self-explanatory. Once you get into it, it's not too bad. So I'm very quickly going to show you how to put a keyway in to a shaft and a hub. Now, at the moment that hub is solid, and this is just has been put through here, but neither one has been modified to fit the other. Okay, so what we're going to do is we're going to come up to here and put in a key. And when it first opens, when you first have this reference 1 open, you will reference that cylindrical diameter there, and that will give you access to the various keys that are available under the ISO standard. For example, you've got all these other standards. You could use a DIN standard if you wanted to, and that will probably give you hundreds of different types. But you can choose a key to go in there. Your next reference 2, will be that face in there, that shoulder. I would suggest you can use this, but then you'd have to do some calculations. But so use that shoulder there as your second reference. And if I zoom in, you'll see that it's accidentally put it the wrong side. So you'll need to use the flip here to flip it to the correct side of the shoulder. It's already chosen the XY plane as being its alignment plane. You can use this button here to drag it round. But what we're going to do now is I'm just going to drag this component right through here. So it's actually sticking through the end of the shaft, at the end of the hub. And that one I'm going to just move the whole thing a fraction that way, away from that shoulder. Okay. And you will need to make sure that this ties in with your all the calculations that you've already done, all the hand calculations. The whole point of getting you to go through that stage gate was so that you could do some hand calculations and make sure that when you came to doing this, you would already know the size of the key that you wanted and where you wanted it. Okay. Now, these 3 buttons down here are quite important. They're all highlighted blue at the moment. I can switch them off. At the moment, that would just insert a key. That will cut the hole for the key to go in, and if I click that one, it will also cut the groove through the hub, and it will cut the hole as well to perfectly match, which you can then tolerance later. So those buttons are quite important, and that's what we're going to do next. So it's now asking me, it's already highlighted this in blue, and it's now asking me what it wants me to reference in order to put the groove through. So we're going to put a groove through from that face, and we're going to choose, say that. So that knows now where the hub is and what direction it's going. So it's now got a cylindrical reference as well. Okay. If we click OK, it will automatically generate, it will create the key, it will cut the hub keyway and the shaft keyway, and it'll dump those parts as it creates them into the folder. So there we are. Okay. Now if I highlight this, right click and do free move, you'll see that it's not only cut through here, it's created the key, but it's also cut through there as well. If you click update, it'll go back. Okay, now obviously that's not correct, but I've just shown you the basics of how to use it. All right, and it'll all be beautifully aligned and constrained correctly. I've done the same here. Now I must just quickly show you the chain drive. Okay, so I'm going to right click and edit using the design accelerator. So the chain drive, what it's done is it's chosen. You can choose all the different chains here. You can choose them by power rating. It'll give you a power rating per chain. You can choose them to match the ones you've already chosen in your catalogue. So I've gone here for a triplex 20B. And then, having done that, you can then specify these. This is very important. These 3 buttons here that highlight, it's going to create a complete new component for you in your model. It'll just build a beautiful sprocket, and it'll be a physical component in your model. This would be if you had imported an existing sprocket. So if you've brought one in from a supplier, then you could use this. And this is a virtual one. I've never used that, so I don't know what the hell that does. But anyway, I would have it on the component setting, because then it will create the component for you. And what it's doing here is it's to ask me, I've told it that I want this sprocket, which has got the number of teeth on that sprocket is 19. It wants to know where it's referenced. And what it's done is I've referenced this line, which was the 1 meter long line in the sketch. It gives you the option to change the number of teeth here. It also means I can grab these grips and it will allow me to slide this along that axis. That was the whole point of putting that in. And you can see how it jumps by the correct number of links. It's actually modelling the links for you here. So I'm going down to 802, so yeah, 835 millimeters. Okay. If I then, this one here was set on XY position, so I was able to just, I've chosen that. If you double click in the center of this grip here, it'll highlight the coordinates, and I just put it at 0, 0, XY. Because that then was the very center of the shaft, and it was on this plane, so it knew where it was on the z-axis. It just needed to know where the center of the shaft was. So I've pinned this driven sprocket here with 57 teeth to the center of the shaft. And here I've done, this is if I go to here, I've got various options. So I've chosen this, which allows me to slide that along this axis. I used that for the drive sprocket, and I used the XY for this one, so that it was actually pinned to the XY coordinate. Okay. So if I do that, it'll rebuild it. It'll just rebuild it each time. That's all you need to know about the chain generator, really. There's lots of other subtleties to it, but that will get you through.